Well, what is this? No magic constructor for initialization of item tracker. Would lose cons qualifier. Sure. Yeah, the problem is that this class simply doesn't know anything about constness. Once you have an instance of this class, you have non-const access. Where exactly is this needed? So theoretically, I need a const unlock base. So I guess I should make a const object tracker. Okay, I'll probably get a tracked const object too and stuff like that. Hello, Fatman, and hello, Ivan. ObjectTracker. I just really don't want to add another const object. Unless it is crystal clear to me that it is needed and how it will work. But yeah, I just know that I cannot get around it. It's just scary to make changes like that, which are pretty big. Well, it doesn't even compile yet. Maybe I should just work around it with a const cast for the moment. Problem is that so item tracker does not know constness, so tracked cannot be a const reference, and therefore what I said. But then we don't have a copy constructor anymore. No. Error unrelated to that. Member access into incomplete graph tracker. Well, it's a .cxx file, so include a header. Error, no member tracked object in cppgraphviz graph tracker. Say that again. Tracked object was deleted. Tracked object is a member function of ObjectTracker, and I'm having a root graph tracker. What is going on? Totally a pointer to a graph tracker. think I only have this. Track what and track red. Access into incomplete type graph tracker. Again, another file. And then, yeah, I think that everywhere where I have tracked object, I should use track red or what. So my current trackers are unlocked types. For example, this graph tracker is, well, it's an item tracker, which is literally an object. Oh, wait a minute, it's an object tracker, okay. And the object tracker is wrapping this, which is an unlocked. So it is an unlocked thing. So we have to lock it before we can get access. The underlying this thing is also an unlocked. You have to unlock it and you get another unlocked. Really? Yeah, this one. Whoa. Yeah, therefore we do not do direct access. Instead we are using this. So that does do an unlock of the thing, and then it returns a read access type or write access type. So that's double, if you can see what I mean. Two locks. Now add node is non-const, I bet. Of course, so we need a write access. Use of undeclared identifier get parent graph. And that was removed. Why? It's not even highlighted. Did it completely get rid of get parent graph? Let's comment it out. Okay, apparently I have a parent graph tracker. Oh no, I don't. I have a parent graph tracker with a thingy as a member, which is a weak pointer to... Probably should use this then. And then do the rest manually or something. There's no comment here. So the graph that this item was added to is stored as a standard weak pointer to a graph tracker, which is again that same item tracker thing. Which has a track red and what. Oh man. You would say, oh, this is a nasty thing. Theoretically, you would say you need a read log here, and then if it is equal 0, then you need to convert the read log into a write log. But that involves throwing exceptions in the case that another thread is trying to do the same thing. And why is that not good? Oh yeah, that's not good because that requires a read to write carry, which I'm not sure I support. It's early in the day, so maybe I should just try it, you know. If I would use a read write log, but I'm not sure. I think I'm not even using a read write log. Let's keep it simple for now. So I'm just assuming a read and write logs are the same thing, which is the case for a normal mutex. And then I can get a write log immediately, I think. So we take tracked what. So I call that W. Now let's construct it like that. Actually, maybe assignment is better here. Doesn't make any difference, of course, but usually I use braces when the write log is being taken, and here it is more like a compilation thing. But yeah, what the hell is root graph tracker? So it's also a tracker. Then why not assign it directly to the parent graph tracker? Ah, this is all nonsense. What am I doing? Sorry, forget it. Why am I editing this? Use of undeclared identifier. Oh, that was the reason. Get parent graph. Yeah, okay, so we don't have that anymore. And then I was looking here, and then I was thinking, looks more or less usable. The only thing I'm worried about is this lock here, which of course being destroyed when we return. Yeah, so the parent graph tracker is a weak pointer. So the lock, let me highlight this. The lock that we take here converts the weak pointer into a shared pointer, stopping it from being deleted. And then we have a pointer to the graph tracker. And then I lock, I think I just lock the object that the graph tracker is pointing to. Yeah, and that is the object that has the shared pointer, the canonical shared pointer. So if I would lose, if I would leave this function, destroying this shared pointer again, then the only way that the object that I just take the right lock on is destroyed is when that last shared pointer is also destroyed, but that is a member of the thing that I just right locked. So it seems unlikely that that happens. When would that happen? Well, maybe it's owned by another thread and that just destroys it. Then that destroy should block, because we're still working on it. I want to check that. So we're talking here about track what that has locked this what here. Unlocked base tracked object. It's this thing here. It is an unlocked base. Okay, so that has been using a reference to a mutex that is an element of the unlock that the unlocked base was created from. Which means that this tracked unlocked pointer was created from, which is the tracked unlock that was passed through the constructor here, or here. So we're passing an unlock to the constructor of ObjectTracker. And that's this thing. So that is the base class of the graph tracker. So that would be this graph here. Which is the object itself, because the tracker is created when at the moment you create the graph. Now it's probably it's a log graph, I think. Yeah, so the mutex of the log graph is being logged. This is then the log graph here, and the item template is derived from tracked object, which is I know it's nonsense. Yeah, this thing is wrapped in something. Well, I guess here unlocked tracked object is the thing. Unlocked tracked object is derived from unlocked, which has the mutex. That mutex then is locked, and now we were wondering what happens if someone tries to destroy that. I think it's probably I have to destroy the graph itself, so I don't have to look at the destructor of the locked graph. It's probably not even doing anything. This object now is assuming that it is thread safe already. It should be locked. So we should be blocked by trying to destruct the base. Oh, wait a minute. No, you're not telling me. No, oh, I was looking wrong. Sorry, we're trying to destroy the graph, I think. Yeah, but no. Yeah, see, that's correct. If we try to destroy the graph, then actually we're trying to destroy the unlocked tracked object, which is the locked graph as a template parameter, which means that that's the locked graph, which is then again becomes a base class of unlocked. But during destruction, first we call the destructor of the current class. So does this one have a destructor? Doesn't look like it. So we're talking about the destructor of unlocked itself. So we first have the destructor of unlocked being called, and then the destructor of the locked graph. Now you really should block then in the destructor of unlocked. I'm having a bad feeling about this. It's not blocking. It has an assert though. Can only be locked when there still exists an access object that references this object. Well, that's true, but it was in a different thread now. And will access it upon destruction. If the assertion fails, make sure that such access object is destructed before the deletion of this object. If the assert happens after main, did you join all threads, etc. So we would assert, because mref will be not 0 if we have it locked. But yeah, instead of assertion, I could also quickly try to obtain the lock on the object, like the right lock here, and then simply block until everything is gone. The question is that not better? Because yeah, well, without threadsafe debug, this would be compiler generated and wouldn't do anything. So yeah, I think I need to get the lock here. It's just wrong. Maybe even not do the assert, or at least the comment is not correct. If I add a lock here, nah, that would still be a race condition, wouldn't it? This is just the destructor of the current class. So if I lock it shortly and I manage to do that, then doesn't change anything. After that, we're going to destruct the base class, which is the real thing. We would still be able to access stuff in the base class. Then I have to reset the tracker before unlocking. And we are not aware of the tracker here. This is just unlocked. Let's go back to what it was. That means we have to do something before calling this destructor from the base class, the derived class I mean. So from unlock tracked object, which is aware of that we are tracking, I should add, it's quite complex I'm afraid. I can add a lock in the destructor of this class so that the lock is locked at the moment we start to destroy the unlocked. But I still have to unlock it again, or I think I have to unlock it at some point, because otherwise all kinds of asserts will fire. I would be destroying a lock mutex. That's equally dirty. I think I will have to rely on external locking, external synchronization as it were. This should not try to destroy an object while another thread is possibly still using it. I don't see a better solution than to state that. In other words, if this is being called, then we have to rely on it that the object will not be destructed from underneath us. Otherwise something else is wrong. And at least we will assert, so in some cases at least. So it seems that these functions are safe. I don't know why they were commented out then. I'm just wondering why I have this. These are so the same. This is the same thing except that it also calls track water red. Yeah, it's just that's the bullshit. I cannot, well, not bullshit, but I can definitely not use get parent graph, because if I want to read log it, I want to read log it. Then I have to cast it to a const object just to make sure that I get the right return value. So I better use different names for them. So then you would get something like get parent graph what and get parent graph red, which especially look like, nah, I mean I can just call this and then I'll call one of these on that. So get parent graph should be replaced with parent graph tracker and then called tracked what or red. Let's keep it for now, but store that again. I forgot, of course. Parent graph tracker. Does it really need another member function? I think it's clear enough, short enough. access into incomplete type graph tracker. Oh. No, what the hell? Does it return a shared pointer or whoever tracked what? Parent graph tracker is a shared pointer, yeah. So I need 2 arrows. That's annoying. There's not a tracked object. So confused. No more tracked object. Yeah. Too few template arguments. Do template. Needs node as well. Hey, Boogle. It amazes me. Well, can you explain why you love it? I mean, I would personally think that you can only like it when you understand what's going on. And I cannot imagine that people can follow it. Because, well, you're not into the project. Let's just write this, try it again. Tracked object, no member tracked object, yeah, I saw that before. So let's take the what and then access it. Node 4 declaration of, oh wait, it's incomplete again in .cxx, so we're just missing a header file for node tracker. And again, tracked object. Set parent graph tracker, that sounds like a non-const function, so we need a right access type, access. And again and again and again. But it gets easier and easier, doesn't it? Now it's just pattern recognition. I have another one, I think. Can you type in tracked object? That was line 110. 110 jump. There it is. Tracked what? Pop. Make. No member named tracked object, and so on and so on. Tracked object, so I'm looking for it now. That's also not going to exist, I suppose. Oh wait, this is a memory region. Oh no, I still use the old tracker for that. So that might just work. Non-const L value reference to item, cannot bind a value to unrelated Initialize is a write thing, not non-const. Therefore we need a write access type. And we can get that by calling track what? Use of undeclared identifier tracked object pointer. It's highlighted. No tracker does not have a tracked object pointer. Excusez-moi. No tracker is just an item tracker. Item tracker is an object tracker. Object tracker has this tracked unlocked pointer, which is an unlocked. Did not want to access that directly, I remember. Yeah, I have to again call one of these. On one of these days I'm just going to remember that. Let's try to remember it now. Tracked red and tracked what are member of object tracker, which is item tracker, which is no tracker, and graph tracker. Any tracker that I have. Tracked what and red. And this is a tracker pointer. Hello, up here. Cool Z. Practice a lot, yeah. Just code yourself. You can of course watch tutorials for ideas, but the best way to learn is to experiment. So we just spend a lot of time on a single little program, trying out everything you can think of, until you know what is happening down to the last bit. And yeah, your own collection of code is your knowledge. So organize it well. So you have everything in a directory, and you can find it back later. So at some point you need to do something again, and the only thing you can remember is that you did it before. And then you have to find that code back, and then you can look at it, and then you will say, "Ah, right, I remember that. Yeah. That's how it was." So say if you would not practice, you would not have that directory with your own code, and therefore you would know nothing. You would know it 2 weeks after you did the tutorial, but 2 years after that you would have forgotten everything again. And this doesn't work. You have to code yourself a lot. I don't know what to do here. I can imagine that the whole get node thing doesn't work anymore. So maybe I should not try to compile it. Or where or how or when do I need to get node? Nowhere. That's what I mean. It's just still not being used. It's kind of surprising, however. Okay, no get node, then I'll just delete it. Let me try to remember though what is this used to give me access to the locked node basically. So yeah, it's just converting. We have a tracker and then we get the pointer to whatever the tracker's pointing to. Definitely not how it works anymore. Ugh. This can just be deleted completely, I guess. If it is even added to Git. Status node tracker. It was added. Was it added or was it not added? Neither. It was added and not changed. It's another possibility, I guess. Git remove node tracker.cxx. Yeah, make no such input files. Configure. Cannot find node tracker.cxx. That's why I was running configure. Is it listed here? It is. Wow, label node test.cxx. No matching constructor for initialization of cppgraphviz graph. Yeah, I killed the label node. I have to do something about that. No, wait, this is not even talking about level node, it's just a level node test. Let me begin with removing the test, I guess. Does hello world compile? Still. Nope. No member named tracked object in graph tracker. That's correct. So that is a right access type. Add node. Remove nodes. Incomplete type. graph tracker. This time in a header. That's weird. Hey, look at it. Instantiation of template. Instantiation of variable template specialization. While substituting template arguments into constraint expression here. While checking constraint satisfaction for template unlocked required here, which is in a .cxx file. Well, they could have fooled me. Why not even mentioning that? Well, it's being mentioning it here. The line 2 includes a header. You see, though they mention, okay, we are compiling item.cxx. We're always compiling a .cxx. Well, then we include the first header at line 3, so there's no code whatsoever, and we go into header. We go into the standard headers, and then we get an error about an incomplete type. And then only if you scroll down, like way down, you see that it is caused actually in item.cxx line 19 instead of 2. Unbelievable. GraphTracker.h. Root graph tracker's protected member. That comes out of nowhere. No, it does not come out of nowhere. Now finally this comment holds. Trying to access it without locking. So we want to access the member function root graph tracker. Which is a member function of item. And most likely we're actually wanting to access that through a locked graph. So locked graph is derived from item template, which in turn is derived from item. Yes, so and that's where the member function was. So we want to get this locked graph here, which means we have a graph, we must lock it. And how am I obtaining that? Well, I'm obtaining it from the tracker. Now we know what to do with trackers. We want to get something. We have to call now a read access type again, I think. So we call tracked red, and I use an auto for that. And this is read access. So let's change the name. And then we can use the read access type to access the member function. And then hopefully that works, because it seems logical. No member named tracked object in, that's the tracked object again, so apparently it worked. Add array is writing, so we do write access. Call it tracked object. Here's another one. Let's get the right access type. Imagine doing this without my API. You would make a billion mistakes. I mean, if you have to call lock and unlock all the time manually on mutexes, you would never find this. What I like about my library, the threadsafe one, I mean, is that you just get compile errors if you do something wrong. Error, no member named tracked objects. Again, tracked objects. So that was the old code, so it's not logging any mutex. Where tracked object is simply returning the thing, but here we only have tracked object is replaced with tracked read access type, and then we have to dereference the access type to get the underlying object. Error, member access into incomplete type. That's again in .cxx. So which type? No tracker. No, not why. Undo. No tracker. No member named tracked red. In memory, memory region owner. Oops. Yeah. Well, I didn't change memory region owner yet, so it doesn't have tracked yet. Yeah, but it should have a tracked object then. It didn't change anything. So what's this did not compile? Why not? No member named tracked object, but now it's talking about. Oh, but okay. So the tracker is the old tracker, and what it returns is a graph tracker. No, I'm not getting that. Let's look at what it actually tries to do. We're trying to print a weak pointer to a tracker. Oh, right. Yeah. So I'm using this to print every tracker. But now I have two types of trackers. So, yeah, I guess I could use an if const expression. If const expression something, do this, otherwise do the other thing. Where the other thing is then the red. Need access type dereferenced. Or maybe put a new version on top and the old one at the bottom. And that then depends on what tracked is. So I can do utils is specialization of v even value, and that means that I want to know that my tracker is a specialization of, and that then holds for I mean, I have to detect the graph tracker, node tracker, which are item trackers. Yeah, I could use item tracker. The item tracker itself is again an object tracker. So we can also use this. Let's use item tracker or not. No, it doesn't even have to be an item tracker. If it's derived from object tracker, then we should do this. No, the other way around. Wait, no, yeah, then we should this. And otherwise, it's probably the old one. So I'll just do that. And then we have to do the same thing up here, theoretically. So if you don't want to wait until we get a compile error there as well. Code duplication, anyone? Yeah, now this whole block has grown a little bit and it's exactly the same as that. So theoretically I could make that a separate function instead of creating code bloat, but so tracker is shared pointer, so now we just call this. I already checked that this is true, so now we do the same thing. Use of undeclared identifier graph tracker. Again, graph tracker is not known here. Why? Oh boy, yeah, it doesn't want me to do that. Is specialization? Oh, wait a minute. I typed graph tracker to be able to jump to it, but I needed tracker. Error, no member named tracked object. There we go again. What? Wait a minute. No. In graph tracker. No member named tracked object in graph tracker. Gotta be kidding me. The tracker is apparently no. I would say this is a graph tracker. Oh, wait a minute. I'm tracking if it's a specialization of object tracker, but it is actually derived from. I'm not sure if that specialization works then. It's I jump to the specialization of and see, but I don't understand it. I don't understand how this works. I think specialization of T. I think it could, it's going to return true if it can find arguments for T. If it can find a T and arguments such that this exists, or no, T, but where T is U, this T is equal to U, and then we find a U with some arguments, which equals to T. It's really badly chosen, I'm afraid. I think it makes more sense to use a U here. That's why I never understood it. So this U is the same as that U, and now this T must be equal to a U. Cannot be derived from U. Yeah, so that's why it's not working. Because my tracker is a graph tracker or node tracker, probably, which isn't even a template. It's just derived from. I need an is derived from specialization of. I can turn it around. Maybe it's easier to detect this one. To turn it around, because this is really specialization of ObjectTracker, apparently. So let's see if that works. Seems that it worked. Call to deleted constructor of standard atomic int. Oops, what? No, right, okay. I thought it was just an int, so I used copy constructor, but really it's a move constructor. So maybe it will move. Will move it. Might even not work either, actually, but. Guess it's happy. A non-const L value reference to type cppgraphviz item cannot bind to value of unrelated type standards shared pointer text. Okay. What is going on here? Non-const L value reference. Why are my curtains still closed? I'll open them. Be right back. Hello, sunshine. Okay, I'm back. I guess that's old code again, right? Old code. Is that the package for me or not? Today's a bit unlikely. Ordered something yesterday. That would be super fast. But no, it's for the neighbors, of course. That's what you get when you open the curtains. Distracted by the postman. It is for me. Nah, it was not for me. It was for the neighbors. Anyway, but they came. They were not home, so I had to take it. Maybe I should stop streaming. Actually, go for a walk while it's still light outside, as it were. Yeah, I'm tired. It's every time tracker trying to convert the tracker to an item. And that was the same as we had before. Yeah, exactly the same like here. No, well, not exactly, because this is a graph. However, if it takes a while before I see that, then it should stop. Recharge a bit. So I try to compile it again, and if we get past this point, if it just works, then well, compiles. Then I'm going to go for a walk, buy some lunch maybe. Yep, definitely got past that. See, I'm stopping, like I predicted. Man of my word. That was just too easy to walk away from, right? Error call to delete it. Oh, that one. Wait, what? Oh, sad feeling. Yeah. Oh well. Oh well. Yeah, I'm going to go for a walk and while I think about this, because I changed this yesterday, I have to admit. It was reading 0 here, and then I thought, why is it reading 0? If I move this thing, should I not just, copy the value? What is mref anyway, right? It's an atomic integer that is either incremented or decremented, and then must be 0 at the moment of destruction. Good question is, before I can go for a walk, I mean, now I was saying that I was going to think about it, so I really need to know my information now. This is being called when constructed copied. Yes, it's just keeping track of the number of times that the current object is pointing to something. No, that's nonsense. So number of times that Yeah, it's the number of objects. No, the number of m unlocked instances that point to the same object. And those are element of access types. So it's a number of access types that are pointing to whatever they're accessing. The unlock that they are accessing. Therefore, the unlocked is moved with a no locking type, then the lock is already set. And that means in the case of a write lock, that reference must be 0 anyway. In the case of read logs, it could be this is a movie. If we move it, we write log it. So it is write log by us. And I would say that mref must be set to 1 here. It's nonsense. I'm so confused because I think that this value is going to be 1, right? And therefore this is going to be 1, but it was 0. Which then only makes sense if it doesn't make sense at all. Though what I don't understand is that my assert has not fired with the 0. Or maybe these move constructors are so new that I never tested it. That is possible. That is a possibility. Let's try to do this. Oops, 1. No. Huh? Should add an assert. the race condition anyway. No, I'll just do this. Oh, wait a minute. I'm calling do write unlock. I'm not responsible for setting mref to 0. Call write unlock on original itself. That calls, or that doesn't maintain a reference count. That's funny. Because this is not maintaining a reference count, it should be 0. That's why the 0 worked. Yep, and since it is 0, you can just do initialize by 0. Lots of shoots. No. readlock is not const either. So this pointer cannot be const. What? Yeah, seems that this cannot be const because it's just really making a change to the current object. Mutex returns a reference to a mutex that is an element of the current object, of this itself. And that makes a change, even though it's thread safe. So either I have to make it a thread safe const and then use a const cast here. I don't like const casts, so I don't know, maybe this compiles or doesn't it? We'll see. Error out of line definition do's unlocked. So yeah, definitely going to be a problem here then. If I am calling it on a const. Copy constructor, read lock, let me think. Yeah, the problem here is that normally you just copy, you know, I mean, you just make a copy. But in this case, I have to lock a mutex that is part of the original. Before I can read original, I just need to read lock it. So it seems to me that this thing really has to be const. And then maybe mutex can be marked const to return a const reference. No. I could mark it const, I guess. We can even call mutex and then log and unlock that on a const object. It's definitely thread safe const, not a real const now. Oh, dude, what the hell? Oh. Did I press caps lock or something? I did press caps lock. So this is an invention of me. Thread safe const means that it might be changed anyway, but in a thread safe way. So it's okay to have multiple threads at the same time calling this function. Just like it is okay to read with multiple threads. Hence the const. And if then we make a change to a mutable thing, a mutable atomic or something like that, then that's not a problem. And then I can either use a const cast on this, or I can indeed make it immutable, which is preferred, I think. But in this case, I call a member function of a base class that is variable. So sometimes it's this, and other times it's something else. Yeah, I could still do it, I guess. So here we have one of them. 1, 2, 3, 4, 5, 6, I think. Multiple here. Let's count that as 1. I should have 6 or something like that. Now these are const. That's good. These are const. Let's go back then. This one is const. Oh, wait a minute. This one is already const. Oh, that's a reference thing. Well, so this one is not const. I should just make it thread safe const, I guess then. And then I do need a const cast, or maybe I can make this one mutable then. Let's try it like that. Mutable. And then here we have a thread safe const. I think that's the way to go. The ref is already const, and then here we have the read write one. So that becomes mutable and thread safe const. And now they are all const, I think. Go back, const. Can't find tag pattern. Well, they're all const, whatever. Let's try this. Oh my god, that was the last thing. At least it compiles. I'm only trying to compile hello world, but well, still. Yeah, well, I'm going for a walk, and now the sun is gone again. Damn it. I'm going for a walk anyway. I'll be back in after my walk. It's now 3 p.m. so yeah, probably before before I eat dinner anyway. And then we'll continue.